Hello, good afternoon. Welcome once again to another session on engineering graphics with me, Yash Chawla from Parul Institute of Engineering and Technology. Today I am having my students with me, as we saw in the first session, Janav, Umangi and Hardik. They will be helping me to demonstrate first session we demonstrated projection of a point using a ball. Now we will use a dandiya, as it is Navratri, to make you understand what is a projection of a line. So let's move on, and at the end of the session Umangi will solve 3 examples for the projection of line using different data and different conditions. So it will clear out what is a projection of a point, a projection of line. Okay, so let's start on with the slide first and have a little bit introduction and a little bit brief of what we studied in the last session as well, and which will be applicable in projection of lines also. Okay, so in this session we will study projection of lines, and then we will solve a few examples for the projection of lines. Okay, this is what we studied last time also. We will have a brief again, so that you understand that what basically are the planes and why they will be used for the line also. So they will be using dandiya, only one, because we are using a single line, and they will be showing you what will be the different planes like. So Janav and Hardik will demonstrate now the planes, different planes.
First, there are 3 types of plane. One is horizontal plane, another one is vertical plane, and third one is profile plane. First, horizontal plane is the parallel to the floor, and vertical plane is perpendicular to the horizontal plane, which is parallel to the wall. And the third one is profile plane, which is perpendicular to the both vertical plane and horizontal plane.
Okay, so this was about the plane. Then moving on, then different views. Janav will explain you how different views come into play on the same. What is front view, what is top view, and what is side view, and how are they formed on the different planes.
When observer is seeing from that side, that means that its front view is on VP and its top view on HP. The view on the profile plane gives both top view as well as front view.
So that's why it is known as a profile plane, because in that we can have the elevation as well as we can have the perpendicular distance from the vertical plane. That's why it is known as a profile plane. And in the last session also I discussed that it is named as vertical plane because when we are viewing an object rightly from the front, if you can see me exactly from the front, you will be able to measure what height I am, what height I am. So that's why it shows me the vertical height. That's why it is known as a vertical plane. And again, if I want to measure the horizontal distance, as we do on the map, we look at the map from the top, and we are able to measure the horizontal distance between 2 points or 2 different places. So that's why that horizontal plane has been named as it is. And profile plane gives us both the horizontal as well as the vertical distance, the horizontal distance from the vertical plane and the height from the horizontal plane. That's why it is known as a profile plane. Okay, so let's move on. Again, the different quadrants, as Janav explained last time also, we'll have a quick brief up of what the different quadrants are like. These are the different quadrants, and we have okay, these are the different quadrants, first, second, third and fourth, and we'll illustrate it again using that. Please.
Same as point line maybe lies in space, that means that any of the 4th quadrant. This is first quadrant, second quadrant, third quadrant and fourth quadrant. If your object lies above HP in front of VP, that means that object lies on first quadrant. If your object lies above HP behind VP, that means that object lies on second quadrant. If your object lies behind VP below HP, that means that object lies on third quadrant. And finally your object lies below HP and be in front of VP, that means that your object lies on fourth quadrant.
Okay, so that was very well put there by Janav. Now, so this is what he explained, that for the first quadrant, if I have an object, then in the first quadrant it will be above HP and in front of VP, and for the second quadrant my object will be, or in this case it will be line, so it will be above HP and behind VP, and in the third quadrant we will have the same, we'll have the line below HP and in behind VP, and for the fourth quadrant we'll have the line below HP and in front of VP. So these are the different positions as defined by the different quadrants. Moving ahead, so this is again for an object, we require these three things: object is required, the observer is required, and the location is required. So we will not discuss this, we have already discussed in the last session. We want the object, that is the line in this case, the observer, that will be the torch, and the plane which are required, which are the reference planes which we are going to use. The next is, there are three cases of projections of lines that are possible. So first is, line is parallel to 2 and perpendicular to one principal plane. So there are three principal plane, again to refresh. We have vertical plane, we have horizontal plane, and we have profile plane. So the first condition is that the line can be parallel to 2, it might be parallel to HP and VP, and then it will be perpendicular to profile plane. It can be perpendicular to the HP and it will be parallel to VP as well as PP, that is vertical plane and the profile plane. So the first condition is that it will be parallel to two planes, that is either HP, either VP or profile, and it will be perpendicular to one of the planes. And the second condition is that it will be parallel to one and it will be inclined to two principal planes. The third condition is that it will be inclined to all the three reference planes. Now in this reference plane, I will just try to illustrate to you that how this is possible using this stick that is there. So we have this, so I hope all the three planes are visible to you. Yeah, so we have this. Okay, so let us go. First we will show you how a line can be parallel to two planes and perpendicular to one plane. So now this is the case. See, I'll use this marker to show you. This is horizontal plane, this is profile plane, and this is vertical plane, and this is the object, that is the line. Now what is happening is that this line is parallel to this vertical plane, and it is parallel to what? The horizontal plane. As you can see, it is parallel to this line and it is parallel to this line, and in the same time it is perpendicular. You can see VP, you can straighten it up a little bit. Yeah, it is perpendicular as it is moving out of VP. You can see it is emerging out of VP. So it is it is perpendicular to VP. This is the first case, that it is parallel to two reference planes and it is perpendicular to one reference plane. This can again be illustrated in the same way. If you do it this way, then what happens is that it is parallel to HP, it is parallel to VP, but it is parallel to the profile plane this time. This is the same condition first, that it is parallel to two planes and perpendicular to one plane. The final condition that is possible is that it can be of this sort. It is now, this is parallel to vertical, this is a vertical straight line. So this is parallel to what? PP, as vertical plane as well as profile plane, and it is perpendicular to what? It is perpendicular to the horizontal plane. So this is the first case that we have discussed, that it is parallel to at least two planes and then it will be perpendicular to one plane. Then the second condition that is there is that it is inclined to one and parallel to the other. How can that happen? It is inclined to one plane. See, I will show you in this fashion. It is inclined this way. As you can see, it is inclined. You can make it a little bit steeper so that is visible. Yeah. So as you can see now this is inclined to this plane, but it is parallel to HP. It is inclined, it is making an angle, this is the angle that it is making, or this is the angle that it is making, and it is parallel to what? It is parallel to, if you can, a little bit straight, yeah. So it is parallel to HP, and it is inclined to what? Vertical plane as well as profile plane. Now instead I can do it in this fashion also. To illustrate, I'll just move it towards the camera and I'll do it in this way. Now what is happening is, this session, yeah. Now what is happening is that its base is lying on HP and it is actually straight, guys. Yeah. Now these both lines, as you can see, this line and this line are parallel to each other. But if you see it from this angle, then you will be able to if you see it from this angle, then you will be able to, if I straighten it up a bit, you will be able to see that it is making an angle with which this line, which is HP, this is the angle that it is making. And on the other angle we saw that it is parallel to what? It is parallel to VP. So this is the case in which the line is inclined to one and it is parallel to other one plane. The third condition is that it is inclined to all the reference planes. So for this illustration I will keep it at the origin. This is the origin, this point is where all the three planes meet. I will keep it at the origin, and if I view it from any angle, it will be making an angle with VP, it will be making an angle, see, it is making an angle with VP, it is making an angle with PP, and again it is making an angle with the horizontal plane as well. So this is the third condition in which it is making an angle with all the three different planes that we have. So case 1 is that line is parallel to 2 and perpendicular to 1 reference planes. So now there are three conditions. So Hardik and Jenna will illustrate one by one all the three conditions, and then we'll have the final result on paper, that how it is drawn.
First condition is
First condition is line is perpendicular to HP and parallel to VP.
First condition is line perpendicular to the HP and parallel to VP and PP. Then you torch.
Yeah, I'll put. तुम explain करो.
Whenever the line is perpendicular to any plane, that means that its top view or any view, that means line perpendicular to HP, so that its top view gives only the point and its front view gives the whole line, that means that length of the line.
So this is the view. See, if I move this slide, so you will be able to see that the line is being shown. This is the line which is being shown. So it is getting a straight line, as you can see. If I move it upwards and downwards, you will be able to see the whole line. I have a small torch, that's why it is the whole thing is not visible. If I extend it backwards and move it this way, you will be able to see the line again. So the parallel, it will be a straight line on VP as well as PP, and it will be a dot on the horizontal plane, which will come in this fashion. As you can see, this is what the paper is getting drawn. So you can see the animation and you will be able to visualize it even better. The HP is drawn, now the VP is drawn. So these are the two planes, and now this is the actual object, the black line AB. Now this is the shadow that is being casted on the vertical plane, that is the front view, A dash and B dash, and now the point which is there on the HP, that is its top view AB. I hope it's clear. Let's move to the next the next condition. The line is perpendicular to VP and parallel to HP.
In this case, the shadow of the line which is on the plane VP, it's a dot point, and that is the top view of the line, and the whole length of the line is in HP.
You can use the torch to show the animation.
Front view of line gives the point on VP, and top view of the line gives true length of line on HP.
You can show it here. As you can see, the top view, you can see this line, this is there, this line is the top view, and when I prove it from the front, this is what happens. And this point, as you can see, this is the point, just a point that is there on the line, which is this one. This is the point that is coming, so that is the front view, and this is the top view of the condition in this case. So let us see the animation. to know that what exactly is the figure that has been formed. This is HP. These are the steps of how to draw in an isometric view. This is just for explanation. In the coming problems we are going to draw the how we are going to draw it on the sheet will be illustrated in the coming problems. This is the front view which is there on VP, and then the same length as AB will be there on what, the horizontal projection, horizontal plane, that is. So this is the second condition. Now let's move on to the third condition. This is the third condition in which the line is parallel to both HP and VP. So it will be perpendicular to what, the profile plane. So they will show you how it is done.
You can see that
Okay, yeah.
line is parallel to HP as well as parallel to VP, and the line is perpendicular to profile plane. That means that its front view
Will be a straight line.
gives straight line, as well as its top view gives straight line, and on profile plane you get only the point.
A single point, exactly as shown in the figure, that it will have a straight line equal to AB. This is our AB, and the same will be projected as A dash B dash, and the same on VP, and the same will be projected on HP as AP, and this will be a point which will be projected on profile plane. So these are the three conditions. Now let us move to different conditions. Line is perpendicular to HP and parallel to VP. So how are we going to draw it on paper? That we are going to see, and we will draw one of the conditions on paper. We will demonstrate it live, and then we will go to the animation and see that how the whole paper thing looks like. We will assume first quadrant, and then we will we'll assume a line in this line in first quadrant, and we'll assume that the line is parallel to VP and perpendicular to HP. It is parallel to VP and perpendicular to HP, as you can see. So can keep it down, yeah, a little bit straighter, yes, good. So now you are able to visualize. इसको सिर्फ hold it by a string.